Here we are going to determine the exact value of cos 5 pi over 12. Now, 5 pi over 12 is not one of our special angles. So we are going to have to break this down into two pieces, whether two pieces that are being added together or two pieces that are being subtracted to determine the exact value. And that means we will have to use our compound angle formulas. So let's take a look at this piece inside here. We're going to take a look at this 5 pi over 12. So 5 pi over 12. If you can think about a way to break this down into two things that are either added or subtracted, when we do that, we need to ensure that those two pieces are one of our special angles. So because we're still fairly new to this, let's try and just convert this to degrees. So to convert it to degrees, we're going to multiply it by 180 over pi, and we're going to find that it equals 75 degrees. So we're going to work with it this way for now until we get comfortable breaking this down into angles and radians when we're more comfortable. So now let's think. What two special angles could we add or subtract to get 75? Not forgetting that our special angles are 30, 45, and 60. Well, because this is 75, I bet you we're going to have to use 45. Well, if I break this into two things, what plus 45 will give me 75? Well, it would be 30 plus 45 gives us 75. So I'm going to be using this and this as my two special angles. Now that we know that, we can rewrite these degrees back into our radians, and hopefully we remember that 30 degrees is pi over 6, and 45 degrees is pi over 4. So in fact, 5 pi over 12 can be broken down into this. And let me actually show you how that could have been done without converting it to degrees. So I could have figured out two things with a denominator of 12 that adds to 5. Well, I bet I know that 2 plus 3 is 5. So 2 pi plus 3 pi gives me 5 pi. And if I then go to reduce this, you're going to find that this reduces down to 6 pi over 6, and this reduces down to pi over 4. So that's another way that you could have figured this out. If you feel more comfortable for now converting it to degrees, then that's fine. But eventually, once you get more comfortable, you should be able to follow it this way. So that means my original cos of 5 pi over 12 can actually be rewritten as cos of pi over 6 plus pi over 4. And now I can use my compound angle formulas and my special triangles to figure out the exact value. Okay. So my next step is to write out my compound angle formula with my two values here. So this is going to look like cos of pi over 6 times cos of pi over 4 minus sine of pi over 6 times sine of pi over 4. All right, so that means I need to draw out a special triangle of pi over 6 to find the cos and the sine, and I need to draw out a triangle with pi over 4 to find out the cos and the sine. So why don't I do my pi over 6's here. And I'll do it here. I'll do my pi over 6 triangle. Okay. So my first step is to draw it out. So pi over 6 is going to be over here. So it's the little angle, so it looks like that. Inside here, we have pi over 6. That was step 1, is to draw it. Step 2, connect it to the x-axis to make my triangle. And I label my sides. Now, because this is a pi over 6 triangle, that means it's a 1, 2, root 3 for my ratios of my sides. Well, I know the 2 is always the hypotenuse, and I know the smallest angle is opposite the smallest side, leaving this guy down here to be root 3. Okay, so that's my step 1 drawn. Step 2, I've labeled my sides. Now I have to find both the sine and cos of pi over 6. Not forgetting that sine of theta is y over r, and cos of theta is x over r. Right? These are the things that hopefully you've memorized. Okay, so that means when I label my sides, this is my r. This is the x component because it's my horizontal. This is my vertical component, which is why that's my y. So when I go to state my ratios, my sine of pi over 6 is equal to y over r. So it's 1 over 2. And my cos of pi over 6 is my x over my r. So it's root 3 over 2. So that is what's going to go in for sine of pi over 6. It's going to be that. And cos of pi over 6 is going to be that. So we're only halfway there because we still need to figure out cos and sine of pi over 4. So that's the next one. We'll do that down here. I'll do the pi over 4 triangle here. So, drawing pi over 4, it's going to sit this about right in the middle. Okay. This being pi over 4. That is little 4. Step 2, connect to the bottom and label our new special triangle. So because this is pi over 4, that means this is going to be a 1, 1, root 2 triangle. And just like here, the 2's always go on the hypotenuse, which only leaves these other two sides to be 1 and 1. All right. Finally, we are going to state our two ratios. So we're going to find the sine of pi over 4, and then we're going to find the cos of pi over 4. When this is my r, that is my y, and that is my x. So sine is y over r, so it's my 1 over root 2, and my cos is going to be x over r, so also 1 over root 2. Okay, but as we know, we've got radicals here on the bottom, and we're not allowed to have that. Okay, so I have to multiply this by something to get that radical out of the bottom. So I am going to, in fact, multiply this by root 2 over root 2. Okay, because this is essentially 1. It cancels, and therefore equals 1. So it holds the original integrity of the question. And I chose root 2 because root 2 is what's on the bottom, and that's what's giving me the problem here. I multiply it by my problem, but I have to multiply it by the root 2 over root 2. So that will actually give me a final answer of root 2 over 2. And I would do the same thing here, giving that also a root 2 over 2 answer. Okay, so that sine of pi over 4 will be that value, and cos of pi over 4 will also be that value. So that's what I'm going to plug in right here. So cos of pi over 6, we got to be root 3 over 2. Next up, cos of pi over 4. Cos of pi over 4 was root 2 over 2. And then we subtract. Now sine of pi over 6, what did we get? Sine of pi over 6 was 1 over 2. And finally, sine of pi over 4 was root 2 over 2. And now we have this. Then we can clean up and simplify. We do that by multiplying my fractions here. When I multiply fractions, I multiply the tops and I multiply the bottoms. So I'm going to keep this as root 3, root 2 separately. You'll see why in a minute. And this will be root 2 over 4. There we are. So now I have to subtract my two fractions, and I can only do that if they have the same denominator, and they do. So I'm all set there to simply subtract the tops. All over now the same denominator. Now, as we all know, it's important that we simplify, clean up, and try and keep our answers in the cleanest, most simplified form so that if we have to then use it again for something else later, it's not going to make it more complicated for ourselves. So I'm actually going to factor this because they both have a root 2 in common. So I'm going to common factor out that root 2, leaving me with root 3 minus 1, and all of that over 4. So that is my simplified, cleaned up answer. If you wanted to double check your work, you can plug all of this into a calculator and you would get a decimal. And you can compare that decimal to what you would have got if you plugged in this into your calculator in radians mode, don't forget. So that's how you can double check your answer. Okay? But again, this is only for double checking purposes because we wanted the exact value, not an approximate value. And that decimal would be an approximate value because you would have had to round. You couldn't write down every single decimal after that. So, but that's how you can double check your work because this is the exact value of cos 5 pi over 12.